Hello, is this thing on? Doot, doot, doot. Looks like it. Okay, hey everybody, welcome back to a reconstituted, resurrected, and redone future in space hangout. My name is Tony Darnell from deepastronomy.com, and I have kind of configured this hangout, and I'll tell you a little bit more about that in a minute. But first, let me just say that I am streaming all of this stuff on YouTube, Twitter, YouTube be nice, okay? Twitch and Facebook on my Facebook page and all of the social media platforms. So let us all get together and welcome the algorithm, shall we? I'm going to stream and create content that you will hopefully find interesting, and you will interact with that content, and algorithms everywhere will be happily, greedily taking our data and doing stuff with it. All the while, we get to enjoy one another's company. So welcome, everybody. Today, I want to talk a little bit about NASA's efforts to protect us from near-Earth objects like comets and asteroids, and they are beginning to ramp up their efforts in this, and this is something I'm very glad for. So what I've done is I have revamped this thing a little bit so that you know what to expect. I'm going to sit here and I'm going to talk a little bit about, in this particular case, I'm going to talk about the DART mission that NASA is going to do, and I'm going to do it without guests because I don't have any guests, but I still plan to have guests, just not every single time. So on the times when I do have guests, it'll be like the old times with the Hangouts. You guys can ask questions from experts, things like that. But on the times when I don't, which will probably be more times than I do have guests, it'll be me and you interacting, and I'm going to use sources from the web to act as our experts, not just any sources. It's going to be actual, like from NASA and stuff. So I'm not going to just make crap up, and I'm not going to be reading like 4chan and stuff like that and giving that information out to you. So, and then we'll interact, right? So I can do things like I can highlight chats. This is from eBone on. I'm going to start calling you that, okay? You're eBone now. On Twitch, and of course I've got people on. And on YouTube, there's Chris from YouTube, things like that. So welcome, everybody. I'm going to be looking at the chats from all of the platforms because Restream puts them all into one thing for me to do. A couple quick questions before I get started. Which MOVA globe is that? This one. The Constellation one. They were sponsors for a while, and this is what okay, so they sponsored a couple videos a long time ago, and I got one for free. So that was my payment, and I picked that one. I wanted the big one that said NASA or Apollo, what was it, 50th or 60th on it, something like that. It was really cool. But that was super expensive, so I didn't get that one. Okay, so let's get started. NASA, believe it or not, is doing something that I think is vitally important, and that is helping us learn and find out about things that could potentially damage us. They've been doing this for a while. They've been doing this most specifically with a spacecraft called NEOWISE, which is a repurposed infrared telescope that was called WISE, which is Wide Field Infrared Survey Explorer. They turned it off because their mission ended, and they didn't have any more money for operations, but then it still worked. So they turned it back on after getting some more funding and called it NEOWISE, with a new scientific mission of looking at wide swaths of the solar system for transient events in the infrared, like asteroids and comets, and then cataloging those and marking them as potentially hazardous or not. I, for one, am very glad that NASA is doing this, because this is I think next to dealing with climate change, this is probably number 2 on the things we should know about, right? Is whether or not a 140 meter sized rock is heading our way. So it turns out that in 2005, Congress passed a law that said, NASA, you must do this. You must, let me read this right here. It passed a law that required NASA to track all comets and asteroids greater than 140 meters. It's a law now on the books that NASA has to do this. It's been there since 2005. Now, as with all things with NASA, poor NASA in this case, they didn't give it any money to do this. It just said you're required to do it. And oh, by the way, which one's pink? You're not getting any money for it. So they have to do this in addition to all the other stuff they're doing without a budget increase. So what they're doing now is they are working on a mission called the NEO surveillance mission. I think they announced it back in 2019, and they've been working on it for a long time now, but it's going to launch no earlier than 2025. So we got about, 3 or 4 more years before it goes up. And it's going to cost about $600 million. Take that with whatever grain of salt you want. But it's funny because right now NASA spends only about $150 million a year doing this kind of work, right? And it's characterizing and measuring any kind of hazardous objects that are heading our way. So they don't spend a lot of money on this now. $600 million is a big increase in that. And so why is this important? Well, it turns out that anything greater than 140 meters is enough to cause a lot of problems here on Earth, right? Something hits us at 140 meters and it could cause a lot of regional devastation. Won't be one of those extinction event kind of things. It needs to be a bit bigger than that, but that's still, we need to know where things that greater than 140 meters are. Okay. So that's why they are tasked to do, that's why they're looking at doing this. And this survey mission, this SEO surveillance mission, which hasn't really gotten a name yet. They're just calling it SEO surveillance mission. Thomas Zurbuchen, the director of the science directorate at NASA, says that they will be able to find 65% of those kinds of asteroids, those 140 meters or greater, within 5 years. And they'll find 90% of them with 10 years of operation. Now, this thing isn't going up till 2025. So by 2020, by 2030 and 2035, we'll have a pretty good handle on where all these things are. But to get started this year, they're going to be launching this thing. This is an artist rendition of DART. DART stands for the Double Asteroid Redirection Test. It's really kind of cool what this thing is going to do, right? It's going to, first of all, it's got that ion drive on it, the same one that was used by Dawn when it went up. It's got an ion propulsion drive. It's got really cool, really new revamped solar arrays and things like that. So that is, but what it's going to do, okay, it's called the Double Asteroid Redirect Test. This is a proof of concept that they are going to be testing out in a couple of, well, actually, it's going to launch in November of this year. November 24th, 2021, this will launch, and it'll launch on a Falcon 9, and it will do it from Vandenberg Air Force Base. So that's the plan so far. So we're coming up on this. This is one reason I want to talk about it today. So in November, they're going to launch this thing. And let me just show you another little, let me just show you another little image of it. Here's a little schematic of the spacecraft itself, what it's going to have. You can see on the sides that it's got the rolled up solar arrays that are called ROSA. They were same ones also used on Dawn, and it's got batteries, and there's the Draco. That's a camera that is going to be used to point it towards this asteroid. And where they're going, what they're going to be looking at is this thing right here. This is a radar image of an asteroid called Didymos, Didymos. And it's going to be where this is a radar image taken from Arecibo before it fell down. And there are actually two satellites here. One of them is the large one. That's Didymos itself. And there's a smaller one right up here. This is a series of what is that? 14 images, 14 frames of observations showing the main body and then the outer moon, which are calling a moonlet, which goes around. That actually orbits around Didymos itself. So the Didymos asteroid, the main body, is 780 meters across, so it's pretty big. But the moonlet, this little tiny thing here, these few pixels right there, that's 160 meters, just that thing. And that's more typical of the size that NASA wants to keep track of and they want to know more about, okay? And so this is a binary double asteroid, and of course it's being watched on Earth and all kinds of other things as well, very closely, okay? So, and then here, let me just show you one more thing. This is a sort of a rendering done with data. This was taken from radar data itself. Make sure this, I could probably make that bigger. Let me just do that. Boop, boop, boop. There we go. That's Didymos and the moonlet right there. And that's taken from data and light curve data and radar data. Okay, so as I said, it's 780 meters across, and the small little moonlet is 160 meters across. Okay, and what they're going to do is they're going to fly to this thing, and they're going to crash into the moonlet. This thing right here. They're going to crash into the moonlet at approximately 6.5 kilometers per second, and it's going to be helped along with that Draco camera, which I showed you earlier. That's the camera it's going to use, and it's going to also have autonomous navigation software, not unlike what they use for OSIRIS-REx. So the collision will change the speed of the moonlet in its orbit around the main body by only a fraction of a second. We're not going to be changing it very much, but it will change the orbital period of the moonlet by several minutes. And that's enough to be observed and measured by telescopes here on Earth. So they're going to crash into this thing at 6.6 kilometers per second. And then they're going to look at the effect that it had on the trajectory, or at least the orbit around Didymos itself. And this is all a test to see whether or not a bigger mission might actually work. I mean, here's well, that's it for now. So I'll show you that other stuff here in just a minute. So that's pretty cool. Now it's going to arrive. Let's see. It's going to arrive in on Didymos. Where does it say it's going to arrive? It's going to arrive. It's going to launch in November, November 24th, and then it will get to Didymos about a little more than a year later in September 2022. That's when it's going to get there. And when and then the Didymos system will be 11 million kilometers from Earth, it says, enabling observations by ground-based telescopes and planetary radar to change the measure the change in momentum imparted onto the moonlet. And here's a few little factoramas on the thing itself. It was discovered in '96 by a guy named Joe, and it's got this designation. There's its aphelion and perihelion, major axis, eccentricity, all that stuff. It goes around the sun once every 2.1 years, and it's got one known satellite with a rotation period of about 2.25 hours, and the distance between the two is about little over a kilometer. So they're about a kilometer apart. And the moonlet is tidally locked to Didymos itself. So that's pretty cool. And they're going to, I think this is one of the more interesting and important missions that NASA's got coming up besides JWST. So I wanted to sort of let you guys know about that. We currently know, we currently know where, like, I think 95% of all the asteroids are in our solar system, and we know the majority of the ones that can be potentially hazardous asteroids, and they're cataloged as such when they're found, but we don't know if there's all of them, if we've got all of them yet. And certainly with NASA being tasked to find the ones that are less than 140 kilometers in diameter, this will help change that quite a bit. And they already know where it is. It's not a threat to Earth. It'll be about 11 million kilometers away when it hits us, and we're going to be able to see, using telescopes on the ground as well as radar images, what effect smashing this little thing in to that moonlet will do. So, and so the idea being, okay, if this works, and we can redirect an asteroid even just a little bit by using something small, then they can extrapolate from this test. And when they go to look at their surveillance mission data, which they're gonna start doing in 2025, then they might get a better idea of what we can do to mitigate an asteroid coming by us. Because let's face it, right now, if an asteroid is coming at us, knowing about it is probably a good idea, but there's not a whole lot we can do about it. It depends on when we observe it, right? How far away it is when we see it. So it's kind of like knowing when you're going to die and not being able to do anything about it if you see a big enough one coming at you. So this is important work. We got to know this stuff. And DART, which will launch in just a couple of months, is gonna help us figure out if we can bang into something and protect ourselves. Yeah, and so let me get some of your comments on this before I get too much further down here. Ebone is commenting, actually, I seriously think this is going to be a good experiment. I agree. I think this will work. Well, it'll work. I mean, we'll smash into it. Whether it'll have much of an effect, we'll see. Architufus, Didymon is specifically chosen because it won't be a threat to Earth, whatever happens. That's right. This is not going to hit the Earth. This is it happens to be a gravitational system that has a component to it that's small enough that DART could affect. So when it smashes in to it, we'll be able to see the effect on it. That's why it's a test. It's not going to hit Earth. I don't think that's, well, you never know, do you? I mean, we're talking, what are we saying here? That it's gonna change the momentum by what was it? Let me go back to that part. It's going to change the speed of the moonlet in its orbit by a fraction of 1%. And the orbital period will be changed by several minutes. So we're talking about a very minute change here. Nothing that will affect, it's not going to fly out and then suddenly head straight for Earth. If we were that good at it, boy, that'd be amazing, right? I'd be able to do that. So, okay, so, and here's from Brian. I believe the planet is going to be hit by a small meteor close to a small city in the next 10 years. Well, I hope you're wrong, but there's certainly nothing to dispute that right now. And it's certainly possible. And the chances are not zero that something could hit the Earth. Now, you've heard a lot about Apophis. It's been getting a lot of attention on my YouTube channel lately. And people are thinking about it. In 2029, this thing's going to fly so close to Earth that it's actually going to be underneath the orbit of geosynchronous satellites, and over 1 billion people are going to be able to see this thing fly by, I think, with their naked eye. That's what they're saying. So this is going to be a world sphincter clutching event, right? Where I think we all just kind of appreciate for the first time just how tenuous things are here, right? And thank you, Hans, on YouTube. I appreciate that. Thank you very much. So, and by the way, it's good to see you again as well. So these issues that we're coming across with world collisions and potentially, life-threatening things are going to, I think, be brought to the forefront at the end of this decade when Apophis flies over. I think people are going to freak. They are just going to freak. All my Apophis videos are going to be viewed 1 billion times. And so, they're going to be wanting to know all about this thing. And if it's, what it's going to do, you're going to hear about it in the news. Just wait, and it gets closer. Scientists are excited about this because they want to be able to study. They actually want to. Some of them want to. I don't know if they'll get their crap together enough to actually make this happen. But some of them want to launch missions that will follow Apophis, put it up in the L2 point, waiting for Apophis to fly by, and then start some thrusters and go right after it and follow it for a while, taking data, things like that. I don't know if that's going to happen. The last Apophis workshop I saw on the internet threw out some ideas, but there was nothing concrete. So, and I've not heard anything since, so I don't know. But it's something that they want to do, and it's going to teach us a lot about asteroids, big ones, because that one's like, I think it's like 500. I forget the size. It's over several hundred meters in diameter, so it's big. It's really big. A planet has just entered the chat. Welcome, Saturn. Welcome. I like your rings, by the way, man. Nice rings. So, so let's see. I'm going through some more. Oh, I already showed that one. I'm sorry. I'm going through these. John Suffel. Hey, John. If an asteroid was going to hit the Earth, just send Clint Eastwood and a bunch of other has-been actors to sort it out. Easy. Not a fan, are you? Yeah. So here we go. This is from Raj. Hey, Raj. Will DART also collect a sample? No, it won't. There's only one mission doing that right now, and that's OSIRIS-REx. I think it's on its way back now, if I'm not mistaken. It'll be here, I think, in another year. And but no, this is a redirect test. Okay, so all they want to do, this is a pretty simple mission. It's only going to cost $600 million, so they say. We'll have to sort of put a pin in that and see if it actually sticks, because we know how budgets go these days. But it's a pretty cheap mission. You build a thing and you launch it up to space, and you hope that it all works, and you measure the results. So here's a picture of. And this is a test deployment of one of the solar panels that is going to go on DART. These are a new kind of solar panel, which are pretty spiffy. So they'll also get to test that technology out as well. So that's pretty cool. And finally, this is their poster. This is DART getting, you can see the moonlets, and you see a little plume where it actually smashes into it. And then you see little observatories down here watching away at the impact of this thing. So that's their graphic for the mission. And yeah, Architufus, you're right. So it's hard to collect a sample after it smashes into something. So no, it won't be collecting it. Here's another one from Raj. Are there any methods other than hitting an asteroid? Well, you mean as far as redirecting them? Sure. This one will teach us a lot about moving it with something that doesn't break up the body. Remember, okay, so yeah, there's several ways we could move an asteroid. We can smash into it and break it up into pieces. That's not ideal, because now we have, instead of one big thing coming at us, we have a whole bunch of little things coming at us. Yeah, a few might fly off, but a lot of them are still going to pretty much hit us. So that's not a very good idea. Same thing with blowing it up, right? Blowing it up doesn't really help you much. Another thing you can do is try and grab onto it with something like a thruster and move the orbit just a little bit. And that gets easier the further away you find it. So if you find something really, really far out in the solar system that you know is going to hit the Earth, and you send a rocket with or a spacecraft with a big thruster on it and clamp onto the thing and then push it, the amount you have to push it way far away isn't as much as you'd have to push it if it got closer. So, but that's another way. Just change the orbit. That has the advantage of not causing a bunch of pieces to come at us. Another way you can do this, and I think this is funny, but it works apparently, is you could take the asteroid, whatever it happens to be that's on course with Earth, paint one side of it in a highly reflective coating, white, or something that reflects the solar radiation really well, and with the idea that the radiation pressure on one side of the asteroid will be greater than on the other side of the asteroid, and it will also act as a thruster and move it out of the way. They say that's going to work. I don't know, but I don't know. It's pretty funny to think about. But that's another way that you can do it. And as Arctufus points out here, there is a gravity tug method where I think you can have a large. Correct me if I'm wrong, Arctufus, but what that does is you have a massive body next to whatever it is you're trying to move, and the gravity well of that moves it just enough to get it out of the way. So that's another attempt at, as with different ways we can mitigate getting rid of these things. Trying to think if there's any others. Do you guys think of any other ones? So let's see. Here's this is from Hans. Hi, Hans. There is almost no gravity, so a simple sneeze will send you away from the asteroid. Yes, there's not, these things aren't heavy, and you're not going to have a big gravitational pull on them when you're standing on them. You could probably jump and put yourself into orbit, right? So yeah. So okay. Raj wants to know about solar sails. Can solar sails be used? So solar sails are these giant, sort of very lightweight, very thin material, highly reflective, that basically are driven downwind by solar pressure, solar radiation pressure, the solar wind, and they move that way and they accelerate that way. I don't know if there's enough solar, because the driving force there is the solar pressure, right? The solar wind. And the solar wind is very, very tenuous. So I don't know if that's enough to make any effect on something about 140 meters in diameter. I honestly don't know. It'd have to be one big mother solar sail, though, if it's gonna have an effect. So Arctufus is clarifying. In that method, this is the gravity well method, you send a probe that will pick a heavy rock from the surface, then it will hover the probe next to the asteroid so that the gravitational attraction between the two can move it very slowly. Really? That would work? You pick, so you got an asteroid coming at you, and then you go there, you pick up a big piece of it somehow, and then you blast off from it and move a little bit off the way up a little bit away from it, and the gravitational attraction from that will move it. I guess it would. Yeah. I mean, so gravity falls off as the square of the radius from it, so, or the square of the distance, so the inverse square of the distance. So I guess, I don't know, I guess that would work. Seems like it wouldn't, though. So Cryptolicious. Tony, I would send a nuclear bomb to one side of an asteroid, then send 1,000 more in sequence to the same relative side. That should deflect an asteroid, no? A nuclear bomb to one side of an asteroid, but not on the asteroid or at the asteroid, then send 1,000 more in sequence to the same relative size. That should also deflect an asteroid. Well, 1,000 nuclear bombs is definitely going to do something. So yes is my answer. It should deflect an asteroid, but the problem here with your idea is that you don't want to blow it up. I guess what you're saying is you just want the force of those explosions to push it out of the way, right? So you've got 1,000 nuclear bombs going off, and then 1,000 more. No, you have one nuclear bomb to one side and 1,000 more on the same side in sequence. I see what you're saying. So you put one, you do one, then you do another, and then you do another, and then you do another, and you just keep firing that 1,000 times until you're driving the asteroid with the shock wave, apparently, of the nuclear explosion off. Yeah, that'd work. It's good use of nuclear bombs too, don't you think? We've sure got enough of them, so that's a good use of nuclear bombs. I think that's a good idea. Okay. Pierre from YouTube, putting another color on the asteroid changes the solar pressure or an explosion close to the asteroid. Yep, that's another way to do it. We just talked, we talked about that. And this is from Daniel Brazula. Remember that scene in Armageddon when some scientists were brainstorming about the asteroid and some failed ideas, including some sort of sail? How bad of an idea was that really? Well, I think that goes back to the solar sail idea. And to me, the question is, and I don't know the answer, is how much solar pressure do you need? And that's going to be a factor of the size of the asteroid and how much you want to deflect it. So if you've got a big asteroid that you need to hurry up and move, I don't think solar sails are going to help you a bit. But if you've got a big asteroid way far away, you might be able to do it, but then you've got less solar radiation pressure out there. So maybe a small asteroid way far out, you might be able to do it. You see what I mean? There's all these things that you gotta think about. And I don't know in the first place if solar sails are worth it in this case. I don't know if they have enough force. But then if you're talking about painting something white, one side white and moving it around, I don't know. I guess maybe there is enough solar pressure to do this. It must, or that idea would be as stupid as it sounds. So, and here's what John's got to say about that. The problem with painting one side of the asteroid or using solar sails is that asteroids rotate, sometimes in odd ways. Cables attaching sails would tangle. Really good point. That's assuming that you've just got a rock coming at you and it's not tumbling, right? That's a good point. And so a tumbling rock on, first of all, you got to land on it, paint one side, get off, it's still tumbling, but then now the radiation pressure is in all kind of different directions. So for a big asteroid, perhaps, that doesn't rotate, which I don't know of any that don't, John's got a point. That's a really, really good point. So nuclear bomb in space, this is from Third Rock, nuclear bomb in space will just create false supernova. False supernova. Oh, you mean all the explosions in space? We'd see them going off? Yeah, it depends on how far away they are. Here's Arcturus. Arcturus. It would take decades, but it can be done. It just won't work if we only have a few weeks to work with. You're talking about solar sails and solar pressure, huh? Okay. Again, how far out do you detect this thing is important. That's a good point. Okay. Hans is commenting, I think the blast will just push out in space, but most of the energy won't push the asteroid. You're talking about the nuclear bomb idea? Yeah. Most of the energy won't push the asteroid. That's you're right. Most of it will miss it, but will enough be, well, and he's talking about 1,000 now. 1,000's a lot of nuclear bombs. You fire 1,000 at them in sequence. I mean, I could do something. Well, we're not talking about, this is from Adam, we're not talking about near Earth space necessarily. Although, yeah, you don't want to be firing these things anywhere near Earth. I've always wondered if nuclear bombs or nuclear material is already in orbit around the Earth. You know there must be, right? Because of all the secret crap that goes on. I mean, you know, just think about W first, right? We found out that the National Reconnaissance Office had a couple of Hubble optical chassis just sitting around spare they weren't using, and gave them to NASA to build W first out of. It makes you think, well, they were just sitting around that where you weren't using them, but how many are you using, right? So there's that, and then there's the fact that, you know, I often wonder if there's like some of these nuclear power RTGs up there and stuff like that. I'm not saying there is, but you know, I've often wondered about it. Nuclear bombs are microscale supernovae. Well, fission bombs aren't, but hydrogen bombs are. You're right. That people, you know, we talk about fusion power all the time, and people forget that we've actually had fusion power since the 1950s. We just haven't been able to control it in the form of a hydrogen bomb. So we have fission bombs blowing up igniting and fusing a core in a hydrogen bomb, that's fusion. And yeah, that would be a miniature micronova, as you put it. This is some cryptolicious. We could put some water between the bomb and the asteroid. The water vapor would damp the force and move it. I don't know. That sounds pretty reasonable. Shock waves in a vacuum. Well, we're not talking about compression waves. We're not talking about compression waves from air. I mean, think about a CME, for example. The sun lets off a solar storm. That's a magnetic event, right? A magnetic eruption that puts out enormous quantities, both of electrons in the form of a plasma and magnetic waves in electromagnetic front. And that interacts with a lot of things. And so that force, in addition to the radiation itself, would be quite a bit of a shock front. So there are a lot of problems with slow thrust and asteroids from Architeuthis. The composition of the asteroid the composition of the asteroid, is it a rubble pile or a big chunk? How fast it resolves? I know there's like a billion things to consider here. I mean, when OSIRIS-REx went to go get that sample off of Bennu, they kind of overdid it. Remember seeing those images? The arm went down, and what it was supposed to do was it was supposed to touch, blow out some air, and then what was kicked up would go into a chamber where it would then pick up and put it in a box so that it could be sent back to Earth. Well, it was so loose. The regolith on top of Bennu was so loose that puff of air was too strong, and it got so much material in it, the thing jammed. The door wouldn't close, and so they got too much stuff. So yeah, and that's just grabbing a little tiny sample of it. So yeah, man, it's going to be what other factors are going to be involved in trying to deflect this thing? All of those things, right? If you tried the nuclear bomb idea and you were talking about a loose collection of stuff, well, you've just blown it apart, whether you wanted to or not. Painting something that loose might be rough. It's a hard problem. It is. And there's a lot of factors. In this case, in DART, with the DART mission, they pretty well, I think, have established using radar what it's made of, at least the moonlet, and they have the masses down pretty good. So it probably isn't going to do much, but they will be able, perhaps, to see the effect on the moonlet from the ground once it explodes. It'll be interesting to see if they do, whether it's loosely packed or just a big rock. So this is from AB. Could you magnetically pull an asteroid with an electromagnet, since most asteroids are magnetic? Well, yes, that's a good point. So you've got an iron asteroid, something with a lot of magnetic minerals in it, then sure, you could grab onto it with some kind of electromagnetic tug. Probably be better, I think, than a gravitational one. But I guess that doesn't work. Not all things are magnetic. Certainly, I don't think Bennu. Well, maybe it does. I'm saying things I don't know. So, why not spin it until it breaks apart? Well, see, I think the breaking apart part is problematic. Again, this thing is heading at us, right? We got an asteroid already on a trajectory to hit us, and worst case, it hits us, and the effect is localized. It is 140 meters or so. It hits us, and a big explosion happens wherever it hits. Devastating for sure in that region. But now imagine you've split it apart. You've got 140. Now, all of this, a lot of it's going to burn up in the atmosphere, but a lot of it isn't. And a lot of it's going to be bigger, slightly smaller chunks going all over the place. And more damage, I think, is possible there than if you just left it together. So it's that breaking apart thing that you don't want. You can't control that. Once you've done it, you've got this main trajectory of an asteroid. Then you've broken it apart, and now you've got all of these parts going in the same trajectory. So the point is to change the direction of everything as best you can, and it's easier to do that if it's all in one spot. You guys have some great comments, by the way. A large asteroid, this is from Chris on YouTube. A large asteroid with a near miss and future intersection would be the use case for that. The use for the nuclear bombs. Is that the one we're talking about? Sorry, but I've got a lot here, and I don't know which thread we're talking about. So, Cryptolicious says water damp the explosion. That's how they blast off doors and walls. Okay, yeah, I don't know. I mean, that sounds reasonable, but I don't know. I don't have much to say about that. Arctufus, a nuclear explosion near an asteroid can hit a single spot on the surface, and that heated surface can exert a tiny bit of thrust on the asteroid. But of course, there's the rotational problem. Yes, that's right. And that's true. There's the energy. Again, you want to finely balance that, but you've got that energy heating one side, which does exert more pressure on one side. And if it's rotating, now it's just kind of doing this sort of, imagine a rocket that's firing and spinning out of control. That's sort of what you've got then, only on a much less effect. Lasers, no, they have not been, Neil. That's a good point. Lasers, presumably you're talking about the photon pressure from a laser highly concentrated at a point. And that's what, in fact, that is a reasonable way to accelerate a lot of things. It's so reasonable that the breakthrough starshot people want to use that exact method to accelerate a little tiny postage stamp sized solar sail or the spacecraft that's attached to a solar sail and pushed out to Alpha Centauri via a laser. Just to do that one little thing, though, is going to require one hell of a laser. I wonder how big of a laser that would require. Let me just look that up real quick. So let's go to break. I was looking up Oumuamua. Let me go break through Starshot. Breakthrough Starshot. I should have gone to the wiki page. The story of, okay, let's see if it says, I'm just looking really quickly for a concept. Let's look at this. It's got a light beamer. With the rising power and falling costs of lasers, consistent with Moore's law, I'm reading this part here, lead to significant advances in light beaming technology. Meanwhile, phased arrays of lasers could potentially be scaled up to the 100 gigawatt level. Breakthrough Starshot aims to bring economies of scale to the astronomical scale. The star chip can be mass produced at a cost of an iPhone and sent on missions in large numbers to provide redundancy and coverage. The light beamer is modular and scalable. Sorry. I'm looking to see if I can find the power. They're saying a gigawatt. That's a lot of power. That is a lot of power. 100 gigawatts is what they're saying there if they can scale it. If I go to the wiki page, oh no, that's not the wiki page. Yeah, it is. Here's the wiki page. Okay, I won't waste a lot of time here. I just want to see if I can see real quickly the laser data transmitter, protective coating, battery, photon thrusters. This is what's going to have on it, potential destinations. Anyway, the point is, here we go. Okay. They would be, okay, so the fleet would have about 1,000 square spacecraft. Obviously, they're thinking positively here. Each one, called a star chip, would be a very small centimeter-sized vehicle weighing a few grams. They would be propelled by a square kilometer array of 10 kilowatt ground-based lasers with a combined output of up to 100 gigawatts. A swarm of about 1,000 units would compensate for the losses caused by interstellar dust, collisions en route, and en route to the target. So Here we have a group of people who want to take something that weighs a few grams and propel it, I mean, admittedly, to a fraction of the speed of light so that it can get to the nearest star. And they're saying that that's going to take 100 or 10 kilowatts placed over a square kilometer for a combined 100 gigawatt output. So let's extrapolate. Let's take what we learned about that and think about an asteroid. 140 meters of iron is going to be pretty heavy, way more than a few grams. But we're not talking about diverting it much, are we? So could a 100 gigawatt laser, if one could be built, be enough to do that? Well, we'd have to do the math, but you know, it would be a big deal, right? Here they're talking about accelerating a few grams to a fraction. I think it's 10% of the speed of light, something like that. And then in using 100 gigawatts to do it. Now they're going to do 1,000 of those, but that's where the 10 or the square kilometer array comes in. It's going to be a big ass beam. So I don't know if that's practical. You tell me. What do you think? I don't think it's going to be within the next decade or so. I mean, we're just now getting around to thinking about this, right? NASA's only just now getting around to smashing something into an asteroid. We just got through grabbing something from an asteroid. I mean, we are in the nascent stages of this. We need to hurry it up if we're going to do something like that. So, yes, RTGs are common for spacecraft, Chris, but they're common for those things that don't stay in orbit, right? Voyager has an RTG. Galileo had one. Cassini had one. I don't know if TESS does. Can't remember. No, TESS is solar powered. Juno is solar powered. So I don't. But there are. You're right. It's very common. What I was asking is, I wonder how many RTGs are in orbit. That's what I'd like to know. So you can. So Raj says yes, they can be used, and he puts a period on the end of that. So done. Thank you, Raj. When can you have that ready? Because I'd like to see that. Oh, now he's added a question mark. Okay. So, well, okay. This is from Facebook. William, welcome. The shooting stars will be radioactive. It's not a good thing. But if we need to, then ... Right. So yeah, we're talking about a lot of radioactivity after nuclear explosions coming down. So now we've added another little thing to it. So I'm not really big on this, on using nuclear bombs to do this, unless we can be real sure we're going to vaporize that sucker, then maybe it would work. Galaxy is commenting on YouTube. The explosions of the nuclear bombs will be an exoplanet's techno signature for life in the universe, especially when we when we put Morse code in the frequency of the explosion. See, now she's thinking ahead, right? Galaxy is going, okay, good. Yes, a string of 1,000 nuclear bombs headed towards an asteroid. If we explode them right, then we're sending messages to the stars, baby. And that's efficiency, right? Yeah, we're about to die from this oncoming thing, but you know what? Here's our goodbye card. And they send out a message in Morse code in nuclear explosions. I love that idea. That's awesome. And that's also efficient, right? You may as well, you're going to explode them anyway. Let's do it at a cadence that sends a message and a signal. And it would be bright, I'd imagine. Thermonuclear explosions are pretty bright, especially ones that are in a long line and follow a pattern. So that's really good idea, Galaxy. I like it. Okay, so AB, can they drag an asteroid with an electromagnet? Because asteroid, okay, we already answered that. Sorry. Another for Chris. Scatter it sufficiently and you'll significantly reduce the mass impacting at a given time. Yes, but you better be damn sure that you do that, right? You want to make damn sure that when you blow that thing up, it is scattered really good and it's been pulverized into teeny tiny particles. Smaller the better. So yeah. Hans, if it breaks apart, the smaller pieces must fly outwards, away from hitting Earth. Well, okay, but like again, You need to do the math on this and make damn sure that your explosion is powerful enough to send all the pieces in trajectories that are not in Earth's path. What you don't want is to go big rock, a bunch of little rocks all come, and then they all still kind of come right at you. You want, how you like that visual, by the way? That really worked, didn't it? So yeah, you want to make damn sure you blow it up big time. I'm not saying it can work, but boy, we're talking about a lot of energy here. But you know what? The payoff is huge, isn't it? We're gonna save humanity. So this is from Daniel on YouTube. Scattering debris shouldn't be that much of a concern if you intercept it far enough, right? Devil's in the details, dude. I mean, yeah, sure. Do it far enough out. Blow it up with enough bombs. Make sure you get all the pieces. Make sure all the little pieces are the size of a grain of sand, so when it hits the atmosphere, we just have a really nice, cool light show. Yeah, do all that, and it's not much of a concern. But I don't know if we're that good at controlling nuclear explosions. Well, you guys love talking about nuclear bombs, don't you? What if the nuclear bomb does not explode? Then you not only have the asteroid to worry about when it hits us. Yes. So, okay. See? So there's more problems. Does it create more problems than it solves? I don't know. It's probably going to be what we do, if I'm honest with you. If today we discovered that an asteroid is on its way and it's going to hit us in 2033, let's say. I'm just picking that out of let's say 2031, right? 10 years from now. And we know what it's going to, and we know with a degree of certainty that's very high that this thing's going to hit. Well, what are we going to do? We're going to probably send nuclear bombs at it. That's probably what we're going to do. That's the only thing we know, and that's what we've got a lot of. The problem is going to be delivery. How are we going to get it there so they explode right? I predict that's what we do. Archituvus is saying we should build a terawatt laser. Sure, man. In fact, I think you should do it. Let us know. A terawatt laser. I can't even imagine. Solar powered too. That'd be Galaxy. Or better yet, put the rhythm of or better yet, put the rhythm of a pop song or the fifth of Beethoven and the frequency of explosions. Dun 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 dun. That's appropriate, actually. Beethoven's fifth. Dun 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 dun. Beethoven would be proud, I'm sure. That's funny. I love that idea. Oh God, we'll need them for the solar sail project anyway. The nuclear bombs? Reality's Voice. This is new from YouTube. Why not just use a carbon nanotube fishing net and drag it to Mars? You don't like Mars, do you? Terraform those green face Martians and save Earth, all for the cost of a large hair net. Yeah, is that what would happen if we smashed an asteroid into Mars? What is the idea that we'd release enough CO2 from the regolith to thicken the atmosphere, and then eventually we'd start it on its way to being terraformed? I should have a hangout on that because I have a lot to say about terraforming Mars. Maybe we'll talk about that next week. There's a lot of problems, but it would get it started. Carbon nanotube fishing net, drag it around. Okay, but all kidding aside, though, that might be the most practical. Imagine we build a net of some kind. And in fact, I think NASA had a mission at one point, I don't know what happened to it, where they were going to try and capture, I think it got canceled, but they were going to do something like that with a big net and capture it and see if they could. Now, we're talking 140 meters and up. So this could be a potentially big net. But we take a couple of rockets or a formation of spacecraft, and we each with the ability to grab onto the net. The net deploy, or maybe they all go together as one unit, and then they split apart when they get there into 4 or 5 or 6 or however many they need, and pulling the net with them, and then going on a trajectory that captures it with the net, and then firing thrusters full blast. That seems to me it would do a better job than painting one side of it white. Especially, course, the problem again, as Adam points out, and Arctupus et al., all of you guys have pointed this out, that the if it's rotating, that's a problem. We got to stop that rotation first. And I don't know how you do that. But that's a great idea with the net. And I wish I could remember the details, but I know NASA had a plan at some point to try and do something very similar. Third Rock from Twitch. The U.S. Navy already has laser cannons and handheld laser guns. Do they? I didn't know that. Reality's Voice. Another question. Why not just use carbon nanotubes? Oh, we did that already. What happened? What's going on with my chat? Are you doing it on several things? The handheld model is named the Laser Diddler. Okay, E-Bone. But how many watts do you need for that? How to produce them in space? I'm not sure what you're talking about now. I'm getting in on a conversation. Architupus is saying it will be a square kilometer ground facility. Cryptolicious says, I'm still going with nuclear detonation powered water cannons that will move rubble piles too, I hope. Yeah, I mean, okay. Third Rock from Twitch. Sad part is it has been released in the last year, but we have had the technology since the 50s. Grandfather had one on the submarine. He was chief petty officer on. This is, you talking about the lasers that the Navy has? Well, what do they do? Do they just, so the lasers I've seen, okay, I admit lasers are getting really powerful. And I remember in the 80s, you had, Pink Floyd planetarium shows that used 2-watt lasers. They were water cooled at the time. I know this because I did the laser shows. And then as time went on, you had laser pointers in the late 90s and early 2000s. They were these red things that looked like a pen, not too dissimilar from this, and you would point and look at things, a little red dot would appear. You could drive your cat crazy with them. And now I've seen them being used in, for example, the sailing world, where you can buy a 2-watt handheld laser. I can't believe this. What used to be water cooled in the 60s, 70s, and 80s is now handheld, and you can put a 2-watt laser up to be used as a signal. Instead of firing a flare, you know how you've seen those when boats are sinking, you can just point this up at the sky. And it's actually, I think you can get one that is approved by the Coast Guard in the United States anyway, as a signal device. I actually saw one of those and it scared the hell out of me because a friend of mine in Miami had one. And that thing was seriously bright. Now, it was easy to blind things with that. You could put a dot on the faraway towers, or definitely use them for, seeing things, pointing at things miles and miles away. But what would one that was designed to damage you do? So you ramp that up. Let's say it's 10 watts, or I don't know, 50 watts. If it's a pulse, are you just going to get badly burned, or does it kill you like in Star Wars? That's what I'd like to know. Are we there? Are we there? Or do we have blasters like in Battlestar Galactica? Because I've never seen anything remotely like that. And God help us if we make those available to people who want to, Second Amendment people who want to open carry them to the grocery store. That's just what we need. So I hope we don't have those, to be honest. Mandy is commenting on YouTube. How can we say that with so many last minute NEOs how can we say that with so many NEOs identified at the last minute? Are you talking about, I'm sorry, I must have missed the context of that. If you're talking about getting it far away or close up, how can we say what? Can you clarify? I'm sorry, I missed the part of the conversation. I'm way behind. Man, you guys are commenting a lot. I need to hurry up. Okay, well, let's see. Here's a fun one. Not buying the filler, and NASA needs a wake up from the far 1999 year. Oops. Yet thanks to those that know, I take care, and I know you do for Earth. By deepest Astro guy. See you later, man. I mean, I'm trying to make sense of that, but I think you're not a big NASA fan, but I don't care. Okay, it's what is so great about YouTube. It's that. Adam altogether. Message says never gonna let you down. Never gonna give you up. I'm not gonna sing. Reality's voice. Didn't they already prove that exploding an asteroid into pieces is pointless as it just joins back together with a short period of time during gravitational attraction? Maybe, yeah. I don't know if they proved it, but it sounds right. Third rock. Also, the nuclear explosions in space is EMP that would reach our satellites, knocking them out possibly. Again, the devil's in the details. How far away are they? Let's see. Pierre is commenting that the idea of nuclear explosion fusion is not new. The physicist Freeman Dyson, but the project was refused by NASA. Are you talking about that one? I think it's called Project Orion, where he had a starship idea where it was a big plate in the back of the starship where nuclear bombs were exploded and accelerated the starship to relativistic speeds. That is actually, I think, a practical idea. I mean, it's a doable idea, but it's also on a scale that we've never built anything like before. So, but yeah, I think I know what you mean with Freeman Dyson. It was the rotation to shatter it, not the explosion. The rotation will send pieces out and away. Okay. You guys love you some bombs. Blow that stuff up. So they need to be small enough after blowing up so they burn in the atmosphere without hitting us. Yes, that's right. Or they just burn up and they don't hit us at all. Galaxy's into making music. I think we should put a techno signature with laser beams in the rhythm of music, preferably the Fifth Beethoven. Dun, 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 dun. Yes. Just put a satellite with an umbrella nearby instead of painting the surface of an asteroid. That's from William on Facebook. Okay. So Archituvus, well, DART's main objective is to explore other asteroid deflections technology solution besides nuclear. A kinetic impactor is something that we can make right now, not 20 years from now. So let's try and see if that's right. Yeah, it's going to be an interesting mission. I think that it's going to be a good test. Okay, you guys, I'm going to have to scroll down because I'm running out of time here. Cryptolicious, he has a comment way at the bottom here. Tony, the 1 mile high global tsunami from a big impact seems worse than any risk of spreading a pile of rubble to me, or no? Sure. Again, we're talking about the details of what's going to happen. There's a lot of ways in which we can be destroyed by an asteroid. I think the thinking goes that an 140 minimum diameter asteroid hitting the Earth would be the minimum that we could control something with, but we have to do something about. Otherwise, anything greater than that is catastrophically high, and anything less than that we can maybe somehow mitigate a bit. I don't know, but the thinking this 140 meter limit just seems arbitrary. But really, they're going to learn about things within a range of those sizes. But yes, so let's say something like that, or even Apophis hits the ocean, and then you've got a tsunami coming at us. Well, that's compounded with all of the other damage from the impact itself. Hitting it on the ground, you have a big explosion, earthquakes, things like that, similar kind of thing. So yeah, all this is bad stuff. Maybe you're right. I don't know. If you want to spread out a pile of rubble and you want to make that risk calculation, then sure. I think you should be able to, I don't know who's going to make that decision, but Dave, I hate to tell you, but I have a 3-watt green laser. Cost me less than, I know, man, they're so cheap. I use it to point at stars and at star parties. I know, dude, that thing must be scary. The 2-watt I had was green, I believe, too. It was green, and I don't know, it was about the size of a, something like this. It was about the size of a stick of dynamite. And yeah, man, and the beam was like a good half, I don't know, maybe a centimeter in diameter. It was a big beam. But yeah, man, be careful with that thing. And anybody could buy them, right? You could just, and they just, you just have them, and can point them at all kinds of stuff. You get prosecuted in the United States if you point those at planes and get caught. But it's pretty hard to get caught, I think. But don't do that. Yeah, and they are pretty cool. Yep, shipped directly from China, and takes a 12-volt battery to run it. So good. Yeah, I mean, just be careful with that sucker, man. Just be careful. All right, guys. I'm going to stop the stream here. This was fun. This went better than I thought. I was a little nervous about going back on YouTube again after so long, but you guys were great. I think you guys protected me from a lot of stuff I didn't want to see, so thank you for that. I will plug my video. So that's right. Third Rock is commenting on Twitch. So JWST is ready for launch now, staged in Redondo Beach, California. They announced a date of December 18th, 2021. I just posted a video on YouTube about this. So please watch it. And it's the first in a series of videos called Countdown to JWST. So please watch it. And let me know what you think. All right, guys, I will be back next week. I also stream on Tuesdays and Thursdays, but only on, right now I'm only streaming on YouTube on Thursday, but I stream on Tuesdays on everything else, Twitch, Facebook, and Twitter. Sometimes on Odyssey, if I can get it to work. So I'll see you on Tuesday if you want to join me on Twitch. Otherwise, I'll be back next Thursday for another Future in Space Hangout, where we will talk about terraforming Mars. I just decided that's what it's going to be about because you brought that idea to my head. So we're going to talk about terraforming Mars and whether or not Robert Zubrin, Bobby Zoo, is full of shit or not. I'll tell you what I think. Okay. See you guys later. Thank you all so very much for watching. And as always, keep looking up.